And now we're good. Okay, so first thing is, guys, I want you to write down the definition of relation. All right, so we have relation, and that is just a set of ordered pairs. There's many ways to make the set of ordered pairs. You can do graphing, you can do mappings, you can do them as a table, lots of different ways. All right. Hey. So again, what I want you to do now is, after you write relation, all right, then the next main thing is I want you to write down function. All right. And a function is when your relation, okay, someone else is now trying to get in. All right, Max is in. All right, so now we're at a full class. All right. Now I know some of you guys are sometimes getting kicked out, and then you have to get back in. All right, and I can see that flashing. So be patient with me because I'm watching two screens. All right. So back to function. A relation is a function if every x has a single y value. Has a single y value. All right, and I'll show you how simple that is. All right, it's very, very easy. But these are the two main things. Also, domain, this is just something else you need to know. Your domain are your x values, and your range is your y values. All right. So those are the main things for today. And honestly, guys, this, some of you are going to like a lot because it's very little math. It's just your understanding of the definitions. Okay. And we're just going to plot some points, which everybody knows how to do. All right. So number one, express the relation below as a graph. So now you're just going to plot 3 points. All right. And I know everybody knows how to do this, so let's not waste any time. We're going 6, and then we're going up to 9. Plot a point. 8, so we go over 8, then we go up 6. And then over 1 and up 3. That's all they wanted you to do. So that's exactly what you're going to be doing on the IXL. All right, exactly what you're going to be doing on the IXL.
Hey, wait, Mr. Stroud, it glitched out and it canceled all my definitions when I was writing them. So yeah.
All right. Now, does anybody have any questions so far on that? All right, I know you guys know how to plot points. All right. All right, so let's go on now to question number 2. All right.
What? Okay.
What's the matter, Connor?
I can't get the definitions down.
All right, hustle up. A relation is just a set of ordered pairs.
Yeah.
All right.
Range.
A relation is a function if all of the x values have a single y value. And again, you'll see in a minute, it's better to do the demonstration, right? And you'll understand the definitions much better, okay? So here we go. Let's take a look at number 2. Now, believe it or not, this is really old school, but we used to call this a mapping. All right. Now, domain, again, is the x, the range is the y. All right, so believe it or not, that's how they used to do ordered pairs. But again, this is still what? The 0.50, 71, and 85. Okay, you're probably never going to see that again. All right, it's just really old school. And so they're throwing everything the different possible ways that you can write it.
Mr. Shaw,
Yeah.
are most of the IXLs going to be like this?
I copied the IXLs.
Oh, thank the Lord.
So no one has any excuse. And I went all the way up to 90 and did every example problem possible, right? So there's no excuse on the IXL. And it's this easy, okay? So now again, we're gonna plot those points. So I just like to put down 3 points and then show you how I'm graphing. All right, 5, 0. Remember, you count over 5, then stay at 0. Over 7, up 1. And then we go over 8 and up 5. Now, of course, everybody's being quiet, and I super appreciate it, but I also feel like some of you are not asking me questions. All right? And this is really easy, so I'm expecting not to have much questions.
The first number is across, and the second number is like up or down, right?
Right, because look right here.
Yeah.
This is the x-axis. That's always done
Yeah.
first, and then the y is done second.
Got it. Okay.
All right, let's move on. Number 3.
Like,
Now, here, they're just trying to trick you, all right? They want you to write the relation as a set of ordered pairs, all right? So 0 is mapped to what number?
20.
Yeah,
20.
right. It's very intuitive. That's exactly right. Then 2 is mapped to what?
16.
Exactly. 8 is mapped to what?
11.
Yes, guys. And finally, 12 is mapped to what?
2.
Look how simple that is. All right. Super easy. And like I said, that's just old school stuff. All right. Number 4. Okay. So you have a choice. Is it either A, this one, or is it B, the second one?
B.
Right. Now, how do I know that? Because 1 is mapped to negative 11. 1,
And
negative
six.
11.
What is only
Right.
and what is only mapped once?
Right.
And,
6 is mapped
Yes.
twice. That's not hard, guys. Everybody good?
yes, sir.
All right, man. Let's go.
Woo!
All right.
Dude,
now,
where's
now,
all this dust coming from?
hey,
Oh,
hey,
shit, I'm not
I can hear somebody. All right. So now express the relation as a table. All right. So instead of ordered pairs, you're just going to put it in a table. So the x coordinate is negative 12. The y is negative 7, negative 11, 6, negative 8, negative 3, 11, negative 12. Now remember, guys, I know this is super easy, so please ask if you don't know something. All right, everybody happy?
Sir? Yes,
All
sir.
right, here we go, number 6. Now, the only difference is you have positives and negatives. So this time I'm graphing 5 points, so I'm just gonna draw 5 points, and then we're just gonna graph them, okay? So here we go, 2, 8, negative 1, negative 10, negative 7, negative 8, 5, 7.
Mr. Stroud,
I'm listening.
for how, I am a little bit confused
Okay.
on like why is it in parentheses in parentheses? It's not very important, but I'm just curious.
No. So listen to me. So so this has to do with sets. Okay. So they're just saying this group of numbers. All right. So you are 100% right, Jack. If I wanted to, it would be no problem if I would have just erased that, and it wouldn't. This is kind of like a formal thing. You know what I mean?
Okay.
Right. You're 100% right. Those parentheses, it's not that it's wrong to have them there, right? It's just saying that group of numbers is what you're graphing. Okay.
Okay. wondering why they're so
No, I appreciate your details. Okay. Okay, guys. Now this one's kind of annoying, right? So to me, the best thing to do is, personally, I would write these as ordered pairs first because I don't like the way it is, right? So I'm going to write -10, -9, -9, 5, -4, 3, -2, -3, 2, -10, and 7, -5. Does everybody see that? In other words, I don't like looking at the mapping because I just never do that. I like just plotting points. All right. So now I have 6 points. I'm just going to put 6 points down and then we're going to graph them together. All right. So now I have -10, -9, -9, +5, -4, +3, -2, -3, 2, -10, 7, -5. All right, does anybody have any issues? Okay. Now here we have to write them as ordered pairs. So let me give you my advice on this. All right. Do them in order. All right. So what that means is start with the lowest X value. All right. Now what I'm going to do is I'm going to show you this right here. That's the lowest X. All right. And then again, you always read this direction. That way there's always a pattern in how you're listing the numbers. All right. So the first number we can see is -4, 5. Then the next point right here is -3, 4. Over here, the next point, 0, 5. Next point, 1, 5. 2, 4. 4, 4. All right, that's how easy it is. Anybody have any issues? All right, I'm happy. Let's look at 9. Okay, now from our notes now, I told you the domain, underline the domain, and then above it, it just wants to know what the X values are. All it wants to do is know what the X values are. The X values of what? The X values of the points that are on the graph. So the quickest way to do that is look there. That first point is a what? -4. This point here, what's the X value? 0. And then what's the X coordinate here? 1.
1.
Right? So now, so now this right here is generally the way you write the domain. Domain, colon. All right, so the domain is those X values. Everybody okay with that? Now the range, what did I tell you the range was? The range was simply the Y values. Now I also tell kids, how do I remember that? I always tell them alphabetical order. D for domain comes before range, X comes before Y. Therefore the domain is the X and the range is the Y. All right, hopefully that makes sense to you. So my range, now you don't list things twice, all right? I also start from small to large. Now it doesn't have to be small to large, but just traditionally that's the way you do it. So -15 is the smallest, then 12, then 15, then 18. Notice how I don't repeat the numbers, all right? You do not repeat the numbers. All right? Anybody have any questions? Again, very simple definitions. Okay?
You
Why?
forgot to 10.
I'm confused on why you put those numbers instead of any of the. Wait, are you just naming all the numbers and not naming them twice, or? I'm just confused.
The range is the Y values. Do you understand that?
Okay.
Come on,
Never
come on,
mind.
guys. Right? The range is the Y. The domain is the X. So I'm just listing the Y values. That's all I'm doing. And I list them in numerical order, and I don't repeat the numbers. All right, here we go. Number 11. Now, in this case, we're trying to find the range. So I'm just looking at only the Y values. All right, this is how I like to look at it. All right, so I don't get confused with the X. So my range, colon. Now I start with the low and go to the high. So now you see why I highlighted, so it's easy for me to read. -5, -4, -2, 4. That's called the range. Very good?
Here, can you slow down a little bit? It's hard to write with the mustache.
Yep. All right, for number 12, listing the domain. All right, D, colon, small to large. Just the what? Just the X values. We're just listing the X values. Smallest X is -13, 11, and 13. How's that, guys? All right, essentially 13 is the same exact problem. Domain. Somebody tell me what the domain is.
-5, 3, 4, 15.
That is perfect. Thank you so much.
Mm-hmm.
All right, here we go. Now, again, now we have to go with our understanding of function, okay? So, is the relation a function? And the answer is no. All right, now why is the answer no? Because look, 1, 2, 3, 4, 5, 6, 7. When x equals 7, y can be 1, 2, 3, 4, 5, or what? 6. If it's a function, y can, x can only have one y value. All right, because x equals 7 has two y values, it's not a function. All right.
I don't understand
Yeah,
it.
what do you mean by like two?
Wait,
Y
Mr.
values?
Strauss, so do you mean that it can only have one
Yeah, just go ahead.
y value over the
Yeah.
the x value?
Yeah, let me say it one more time. See how x can be, when x is 7, here's what I'm trying to say one more time.
Wait, but why does X have to
Just
be?
let me show you. Just listen.
All right.
So if x is 7, y can only have one number. X being 7 can't have two different values. So in this case, 7 can be, at x equals 7, y can be 5, or y can be 6. Each x value has to have only one y value. When x equals 7, there are two y values that can fit with 7. All right. Now, what we also do in math is we say, if you're given a graph, what you can do is we say you can look at it's called a vertical line test. All right. So what exactly does that mean? That means if you take this vertical line and you pass over all the points this way, it can only have 1 point for each x value. So because at this value, there are 2 different y values, it is not a function. All right, it's not a function. All right, now I have lots of examples. Okay.
That makes a lot more sense. Thank you, Mr. Shaw.
Yeah, you're welcome. All right, so everybody take a look at number 15. All you have to do is look at the x values. Are all of the x values different? And the answer is what? No. Therefore, it is not a function. Every x value has to be different in order for it to be a function. It's just really that simple. So look at 16. Now, again, I want to make sure you guys are hearing me on the vertical line test. This is the easiest way when you're dealing with graphs. Draw a vertical line. 1 point, 1 point, 1 point. So do all of the x values have different y values? And the answer is yes, that is a function. All right, let's try the next one. Is this relation a function? Yes or no, guys?
Yes.
Yes, of course.
Yes.
Yes, because all of the x values are different. Is 18 a function?
Yes.
Yes.
Yay, good.
Yes.
Yes. Okay, now on 19, they're asking which relation is a function. Is the first one a function?
No.
No, thank you. Because 7 has 2 y values.
Oh, okay.
What about the second one? Is that a function?
No.
No. Is the third one a function?
Yes.
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 Yep.
And the fourth one?
No.
Definitely not. Told you guys, it's very easy once you get the hang of it. All right. So now everybody look at number 20. Which one is a function?
The last one.
Yes. Thank you, whoever said that. Everybody good?
Yes.
All right. Is this relation a function, number 21?
No.
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 Okay, now these are the tricky ones, guys. All right, so I want everybody
Someone's unmuted.
to take this vertical line, and we're going to just scan across. Is this a function?
Yes.
Yes, it is. Now, the only confusion might be at this point right here. That appears like it might be.
Do the not filled in circles count? Like the ones that are not filled in don't
That's
count?
exactly right. The ones that are not filled in do not count. That's exactly correct. All right, so 22 would be yes.
If they don't count, then why would they put them there?
Well, because you're going to learn this later when you get to higher math, actually. All right, it's this line right here is everything on there except at the very last point, 1, 2, 3, 4. At x equals 4, it's not this point, but it comes up here to this point. All right. Now 23, everybody should be good with on this one pretty easy, right? Is this a function? Is that a function, guys?
No.
No.
Definitely not. Thank you. All right, now I'm going to grab my vertical line again. Is this a function?
No.
No. Is this one a function?
No.
Yes, it is.
Yes, it is. 25 is yes, and 24 is no. All right, guys, let's see what's next. All right, now 26. Is 26 a function? Draw a vertical line.
Yes.
I like what you said. Yes. Go this way, it only touches the vertical line at one spot. So 26 is definitely yes. All right, what about 27?
No.
Very
Wait.
nice, very nice.
Yeah, no.
Because at that point right there, there's
Yep,
two
they both
lines.
hit.
That's
Yep.
exactly right. So that's a no. 28, let's draw another one.
Yes.
28 is yes. Now listen, here's where I'm trying to get you guys involved. If you're not sure why I'm saying yes and no, now's your time to speak up.
For I think it was number 26, it touches the vertical line both times.
Let me see. Where at?
Like right there.
No, because that one right here, and that's very good. That's an open circle. It's not closed. If it was filled in, then it would say no. It's not a function. Okay. All right. Here we go. Now, let's look at 29. You're supposed to. I'm going to label it like this: 1, 2, 3, or 4. I want someone to tell me which one is the function.
Number 1.
Number 2.
I'm saying 2.
Number 1.
Let's look at number 2.
2.
All right, so here we go. I'm drawing the vertical line. I'm going to make a skinnier vertical line. All right, here we go. Here's my vertical line. Well, now I can't make a straight line. Okay, here's my vertical line. As I'm passing through, does it touch at 2 spots?
No.
What's that right there?
Yeah, it
I
does.
thought we're going off of just the circles, though.
Oh, I can't help that.
Wait.
I didn't say you were just counting the circles. I said anywhere on the graph, if they overlap, it's not a function.
Okay.
You see how 2 is not a function, so put a big X on that. Now, some of you said 1, so I'm gonna jump to number 1. As I move it over, does it touch at more than one spot? I don't think so, right? So 1 is correct. Those of you guys who said 1, you're in good shape. Okay, let's look at this one again. Make sure you get it right. Double check if you need to. We're gonna draw a vertical line. All right. Now, let's hear it, everybody. Which one is the function?
The third one.
Yay, the third one. Very good. All right. This one, this one right here was easy, not a function. This is not a function. At that point, not a function there. Okay, so very, very good. All right, now we're practicing our equations. Some of you need some extra work on this. All right, so what I'm going to do is I'm going to go down and do the odds. Then I have some extra practice with fractions because some of you need help, extra practice on that. All right, please, please, please show your work. We need help on this. All right, some people. Some of you guys got it down easily, so it's not really a big deal. All right, but every day we're going to have 10 extra solving equations and 10 fractions. All right, I'm going to go down and do the odds. You guys are going to do the evens for homework. What?
So we also have to do the IXLs as well?
The IXLs probably will take you 20 minutes.
Oh, okay.
And besides the fact you guys have lots of time on your hands. All right, so here we go. Everybody look at number 1. All right, let's get to work. All right, we're trying to make sure that you're moving always moving the variables to the left and the numbers to the right. Please speak up. This is what I'm expecting. Minus 2x, minus 2x, plus 18, plus 18. Anybody have any issues? A lot of you guys said I have them confused, all right? So here we go. Now, keep in mind now, these cancel, cancel. Negative 7x minus 2x, negative 9x equals 27 plus 18, 45. Now we divide by negative 9. X equals negative 5. Any issues? All right, number 3, it seemed like this is the one most people had trouble with. This, again, is a proportion. All right, because it's a proportion, we're going to cross multiply. So we're going to multiply this, all right? That's 6x minus 9. Well, I don't want to skip a step on that. I'm sorry, guys. All right, I want to write down 3 parentheses 2x minus 3 equals 2 parentheses x minus 4. Now, if you can skip that step, I'm totally fine with you skipping that step. Okay? All right. So now we're distributing properly. 6x minus 9 equals 2x minus 8. Now we're going to subtract 2x and add 9. 4x equals 1. Cancel, cancel. Now, divide both sides by 4. X equals 1/4. Now, please, please, please speak up. Speak up, speak up, speak up. Anybody have any issues with proportions? Cross multiply. And then your goal is always to try to get the variables on one side and the numbers to the other. All right, so let's take a look now at number 5. Now here's where some of you made a mistake. Some of you like to try to divide by -2 here. We're not dividing by -2. The reason why we don't divide by -2, because if you're going to divide by -2, everything has to be divided by -2. All right, so we're not going to do that. All right. So on everybody, first thing is distribute the -2. Distribute the -2. When you distribute the -2, you end up with negative 14x plus 10 minus 11 equals 33. Anybody have any issues with that? Okay, now the next thing really we want to do is we want to combine terms. These are already on the same side. So I want to combine those first, all right? I want to combine 10 minus 11. 10 minus 11 is -1. So negative 14x minus 1 equals 33. Now I add 1. Negative 14x equals 34. Divide by -14. Divide by -14. Now, x equals, you must reduce the fraction. Divide by 2, divide by 2. Right? 34 divided by 2 is 17. 14 divided by 2 is 7. Anybody have any issues? Any issues?
It's like I get lost like about halfway through it because it just becomes so long.
So listen to me. I don't want you to tell me you get lost about halfway through. What I want you to do is I want you to tell me where you're not understanding me, kiddo. Because again, I'm trying to show you it's just a process. All right. Every single time there's a few rules that you have to remember. And in this case right here, I can't help you. The only way you get better is by practicing. You have to understand you're combining terms. Your ultimate goal is to get the variables on one side and the numbers on the other. That's your goal. This right here is a number. That's in the wrong spot. That has to go over with the numbers. The variable, there was only one variable, so we were in good shape on this one. All right, I totally understand what you're saying, Tucker. That's why I'm saying, please practice. The more you practice, the better it's going to get. This determines how well you're going to do. All right, you can't go soft on this. If you don't know, practice, practice, practice. Instead of video games, practice your math. All right. Now, on number 7, everybody should look at number 7 and say, this is a contradiction. X minus 2 cannot equal x plus 7. All right, so this, we say, is no solution. Now, let's say for some strange reason, you were just doing these problems and you didn't recognize that right off the bat. Well, watch what happens. If I move my variable to the left and I move my number to the right, something happens. Everything on the left side cancels out. The x and the negative 2 and the 2 cancel, so I end up with 0. And then this cancels. Does 0 equal 9? No, 0 does not equal 9. Therefore, it is no solution. All right? Now, number 9. All right? I'm going to give you a minute. I want to see what you can do. All right, I'm going to pause the video. I want everybody to have 1 minute, and I want to see if you can get number 9 correct. Go. Okay, so the first thing is distribute the negative 3. Distribute the negative 3. So first step, negative 12x minus 18 equals 8x plus 12. All right, again, we're trying to move the variables to the left and the numbers to the right. So from here, I'm going to subtract 8x, subtract 8x.
Mr. Shroud,
Yes,
why wouldn't you subtract 18?
you're adding 18.
Oh,
It's always the opposite when you're moving it. Notice there's a minus. Go ahead.
Wouldn't you be dividing 8 because it's
No, I haven't combined. You have to combine the terms first. You have to combine the terms. The last thing you're doing is you're dividing to get rid of the order of operation. You're working backwards.
so we weren't supposed to keep the addition sign from the parentheses. So when you distribute everything from the
No, listen to me. Here's what I'm trying to get you to understand. Ready? Here's what you're missing. What's negative 3 times positive 4?
negative 12.
What is negative 3 times positive 6?
Negative 18.
That's why it's negative 18 there.
I get that.
Okay, so now what are you having trouble with?
So
now you're supposed to look at this and say 8x is in the wrong spot and negative 18 is in the wrong spot. So I need negative 18 over on this side and I need the 8x over on this side.
Yeah, I accidentally brought the addition sign down from the parentheses.
Yep,
when we
that's the most common mistake. Now you learned something. Very good. All right, very good with that. All right, now this cancels. This guy cancels. This guy cancels. So negative 12 minus 8, negative 20x is equal to 30. Divide both sides by negative 20. X equals, the zeros cancel, negative 3/2. Everybody okay with that?
Yes.
All right. Hopefully you feel a little better. Please, every day we're going to do 10 more. All right. You guys need the practice. All right. Here we go now. Next.
Wait, can you? I still need to write down everything.
All right.
Okay.
Here we go. Now we're going to do the fractions. All right. And I'm going to do 5 more of these. All right. Adding, subtracting, multiply, dividing. All right. No calculator. All right. Here we go. Common denominator. Now, for me personally, I like to do the fractions 4 2/3 plus 6 5/7. All right. Come on, guys. Common denominator is 21. Now listen, I know some of you guys don't like to speak up, but I cannot help you if you don't speak up. All right, is everybody comfortable with the common denominator being 21? Now I have to multiply this by 7.
Yeah.
Now multiply this by 3. So I now have 14 over 21 and 15 over 21. Now when I add these together, that's 10. And now I add 14 and 15. That's 29 over 21. Anybody have any issues so far? Now, obviously, we cannot leave it as 29 over 21. 29 over 21, 21 goes into 29 one time with 8 left over. All right, so your final answer, 11 and 8 over 21. Everybody good with that?
Can't we reduce that?
What?
No,
Which one?
Never.
No, you're right. We cannot. You always check to reduce. That is correct. All right, here we go. 13. All right, now a positive times a negative is always a negative. All right, now the only time when you're multiplying, you have to put them as improper fractions. So 5 times 3 plus 3. Now we're looking to reduce. 18 and 27 can both be divisible or divided by 9. So that's a 2, that's a 3. Now we're looking at 5 and 10. That becomes a 1, that becomes a 2. 2 times 2, 4, 1 times 3, 3. So my final answer to that multiplication is negative 4/3. When you get to advanced math, we can leave it as an improper fraction. All right? Everybody good? Please speak up. All right, let's check out 15. All right. Now, they're both negative. So because they're both negative, that means we're going to add them. All right. So again, I like to negative 2 3/8, negative 6 3/4. What's common denominator? 8. This one didn't change. This one I multiply by 2. 6/8. All right. Now, again, they're both negative, so we're adding them. So this becomes 9/8, and this is -8. 9/8 is the same as 1 1/8. So this altogether is -9 and 1/8. Come on now. I'm doing the fractions for probably about 5 or 6 of you. Anybody have any questions? I'm trying to just make sure that you're excellent with fractions. All right, let's move on.
Since it's 2 negatives, wouldn't that make it a positive?
No, that's when you're multiplying, remember? If
Okay.
I remember if I
add
owe,
the big numbers.
well, it's more like if you owe 2 and you owe 3, you owe 5.
Yeah.
Right? 2 negatives you add. All right, so now here, let's look at this, okay? Now, in my personal opinion, what I would like everybody to do is try to create a plan here. This one's a little bit trickier for kids. So what I like to do is I like to break it down, right? And let's just add those first. Now, why do I say add those first? Because they're both negative, right? So off to the side, we're going to do -6 1/2 minus 4 2/3. Now, some of you are good enough. If you just want to do them all three at the same time, you can. But I feel like this is the best way. All right. So the common denominator here is 6 multiplied by 3 multiplied by 2. So this is 3. This is 4. So this is -10 and 7/6, which is the same as -11 and 1/6. Does anybody have any issues with that? Now, I'm going to add to that 5 3/4. Now, am I really going to add these fractions? Am I really going to add these fractions? Yes or no?
No.
No, definitely not, because one's positive and one's negative. But I still have to get a common denominator. Common denominator is 12. 12. Multiply by 3, multiply by 2. So this is 2/12 and 9/12. So now I have a big problem because I'm subtracting. All right. Now, what I'm going to do is I'm going to rewrite this over here. -11 2/12 plus 5 9/12. Since I'm subtracting, I want everybody to look at this. 2, we can't do that subtraction, right? So we have to borrow. All right, we have to borrow. So I'm going to, hold on a second. I'm so mad at myself. Oh no, I got the recording back on. Okay, I thought I didn't. All right, so now we have to borrow. All right, so I borrow 1 from the 11 and I make it 10. And then remember, you add these two together. 2 plus 12 is 14. Now we can do the subtraction. 14 minus 9 is 5/12. 10 minus 5. And don't forget, it's negative. All right? So this one, I need everybody to double check and make sure you understand what I'm saying there. All right? Lots of ways you can do it. All right? Now, number 19, last one for today. Division, multiply by the reciprocal. So 2/3 times 6/7 times the reciprocal, 14/9. Now, you can cancel as long as one's on the top and one is on the bottom. So 7 goes into 7 once, 7 goes into 14 twice. 3 goes into 3 once. 3 goes into 6 twice. Can anything else cross out? No. So now again, we're going 2, 2 times 2.
Mr. Stroud,
Yeah, yes.
something could cross out.
What?
You flipped your last. Oh, never mind. I'm sorry.
Don't be sorry. Don't be sorry, man. I'm
I
glad you're
didn't see the
involved.
division sign.
Jack, please, thank you very much.
Mr.
Okay.
Straw,
Yes.
wouldn't it be a bit easier if instead of doing 3 and 6 and changing 6 to 2, you could change 6 to 2 and 9 to 3? Because then it'd just make it a smaller number for both sides, not just one.
Well, it's ultimately the same answer. Do you agree?
Yeah, I was just saying.
No, I appreciate what you're saying. What I'm saying is it really, you're right. You can do it that way. You'll get the same answer. All right. So technically it doesn't really matter. If you do it the other way, I'm totally fine with that.
Yeah.
Okay. Makes no difference. But the ultimate solution was 8/9. Okay. Now listen, guys, I don't have much longer with you guys, and I'm really, really, really trying to make sure that you have all the fundamentals. And the fractions and the equations are something you have to know in order for us to do better. Okay, so please let me know. All right, this was our longest class, and I think it was good because we're reviewing fractions and equations. All right, please take the time to do these and then submit it back. All right, now again, I'm going to kind of look at it. And I want you to show your work. The IXL should be simple, simple, simple. All right. Now, again, all this work isn't due until the next class period. All right. So don't stress out over it. I prefer accuracy and I prefer hard work. Don't rush through it. If there's never reason to stress about math. If you don't know something, just text me and I'll try to work you through the problem. Right. But I also think some of you are not spending time. If you don't know something, go back and listen to the video again. If you missed an explanation, go back and listen to it again. All right, Jack, what you need?
When is our next class?
I think I can double check that for us real quick. Our next class for 701 is Thursday. So we meet on Tuesdays and Thursdays. Okay. You guys can do it. I promise the IXL is super easy. All right, who has a question now?
Mr. Stroud?
Yes, sir.
I turned in. Is it possible I could get some credit for?
Yeah. You just anytime you turn something in or finish something, just send me a note. All right. I just literally have hundreds of emails, and I'm doing my best to get through everything. All right. If it's not taken care of, just keep reminding me. All right.
It was the class 7 solving all equations, I think.
Yep. I'll look at everything. Just send me another note if I haven't fixed it.
Thank you.
Okay. You're welcome. Who else?
Which is the IXL we're supposed to do?
Yeah, up to 90.
No, but which ones?
It says right at the top, doesn't it? IXL Q1, Q2, Q4, Q5.
Oh,
Okay. Q1, Q2, Q4, and Q5. All right, if you don't have any other questions, you can just get off. I appreciate you guys listening and working so hard. All right, please keep up the work. All right. Take care, kiddos. Have a great day.
Thank you, Mr. Stroud.
You're so welcome.
Thank you. Bye, Mr. Stroud.
Take care, guys. Take care. Let me know if there's any problems.
Yeah, Mr. Stroud, I just don't get these fractions.
I was also going to say.
No, I'm just kidding. But really though, can we do these? Can we do these the rest of the year? Because this is like my one math thing that I'm good at. So.
Yeah, me too.
We'll just do this.
Can we just drop everything else? We don't need to know any other math.
Right, and what we'll do is what we'll do is let's just do this for all of next year too.
Yeah, no, that would be good because they said we're not getting back into school until next year. So we could just end this year off with a clean sweep of fractions and then forget about everything
Yeah, you know, we're going to start school
Yeah.
2 weeks early too. Did you know that?
Yeah, I did, unfortunately.
I voted 2 weeks.
But I mean, like, there's so many weeks off though, like this.
Yeah, but I said we should extend it 2 weeks into the year, like end 2 weeks late and start 2 weeks early. They didn't like that. So, all right, you guys have a great day, man.